Okay, so here are the notes for exponential growth. So the essential question is, how do you find the asymptote of an exponential growth function just by looking at the equation? So our main idea for today is exponential growth functions. So make sure you put that in the left-hand column. So first, we need to define asymptote. And an asymptote is a line that a graph approaches more closely and closely, but never touches. So we'll be on the graph putting the asymptote as a dashed line. So that will be part of what you have to put on the graph. So the asymptote is a line that a graph approaches more closely and closely, but never touches. Okay, so now we have the exponential growth parent function. So it's always in this form, y equals b to the x power, but the b, which is your base number, has to be bigger than 1 for it to be growth. So it'll go through 0, 1, and it rises from left to right, so that's your growth. And it also goes through the point 1 comma whatever b is, whatever that base number is. Because if I put b to the first power, if I plug in 1 for x, so b to the first power is just going to be whatever the b value is. So our domain for exponential functions is always all real numbers. Now notice here, this is leveling off at this horizontal line right here. That means this horizontal line is the asymptote. It's going to get closer and closer, but never touches. And so this is the equation y equals 0. Anytime you have a horizontal line, the equation is y equals a single number. So this one is where y is at 0, so that's why it's y equals 0. The range will always match the y and whatever this asymptote number is, which in this case is 0. And then it's going to be y is greater than 0 because we're using all the y values above the asymptote. If we're using the values below, like if this was flipped and reflected over the x-axis, then it would be y is less than 0. We're not going to put equal to 0 because it never touches. That's the asymptote. It gets closer and closer but never touches. Okay, so let's practice. And you can practice by putting this into your y equals in your graphing calculator to pull some numbers off the table. To graph each function, state the domain and range, state the asymptote of the graph. So the domain is going to be all real numbers, like we said. So let me make a table here. And you're just going to need to do, at the very least, 2 points. So I'm going to plug in easy numbers here. I'm going to plug in 0 for x, and I'm going to plug in 1 for x. Those are easy to evaluate. So if I were to try and figure out the y value, 3 to the 0 power is 1, because anything to the 0 power equals 1. Then I'll plug in 1 for the exponent. Well, 3 to the first power is just 3. Okay? Now, just by looking at the equation, your k value at the end, because remember when we did all the shifts with the h and the k and the a and all that stuff in functions chapter, the asymptote is going to be this k value at the end. Well, remember, if there's not a k value, that means that is 0. So then my asymptote is going to be y equals 0. Just like the parent function, here there was nothing after it, so that is plus 0 is what it is assumed to be if there's no k value at the end. So then that's where that was. So then on your graph, you do have to graph the asymptote, and I want you to use a dashed line for that. Okay? Then I'm going to graph 0, 1, 1, 3. So you get a point for putting the asymptote on the graph. You get a point for graphing at least 2 points correctly. And then your third point is that you put the shape in correctly. So just the graphing part, 1 point for the asymptote, 1 point for graphing 2 points correctly, and then 1 point for the shape. And then you have the blanks to fill in. They're 1 point each. So this will be a 6-point problem. So then range, remember this matches. And then we look at the graph and we're using all the y's above. So then it's y is greater than 0. Okay? All right, so go ahead and pause it for a minute and see if you can do part B on your own, and then unpause to check your answer. Okay, so if I'm just looking at the graph, I'm going to go ahead and do the asymptote since there's no number out here. That's like saying plus 0. So the asymptote is y equals 0, and I'm going to put that on my graph. Okay, then I'm going to make a table and plug in easy stuff again. I'll plug in 0 and 1 for the x value. You can pick any numbers to plug in, but I always like to pick easy numbers. So then I would do 1/2 times 4 to the 0 power. 4 to the 0 power is 1, because anything to the 0 power is 1. So 1 times 1/2 gives me 0.5, or 1/2. Okay, then we'll plug in 1. So 4 to the first power is 4, and 1/2 times 4 is 2. Okay, so those are the points. So 0 and 0.5 would be right here. 1, 2, and then my shape, domain, all real numbers. And remember, range matches the y and the 0, and we're using everything above, so it's greater than 0. Good. Okay, so just like we talked in the functions chapter, we have translations. So remember the a in front, if there's anything in front of that base number multiplied, it makes the graph steeper if that number is bigger than 1, or it makes it wider if it's less than 1. We also need to add here that if a is less than 0, which means if a is negative, it flips the graph on the x-axis. So that's what we learned in functions chapter. H will occur up in the exponent. And remember, the h is right or left, but it's opposite of what it looks like. So you go to the right if it's a minus h, and you go to the left if it's a plus h. And the k value, just like we talked before, is at the very end, and you keep the sign. So you go up if it's plus k, down if it's minus k. And then your asymptote for exponential functions is that horizontal line, and it's always y equals whatever that k value is at the end. Keep the sign. Okay, so let's do part example 2. Describe the translation of the graph compared to its parent function. So we'll say what it's doing compared to the parent function. State the asymptote, state the domain and range, and we're going to graph it. Okay, well first I'm looking at for my asymptote, so it's this k value at the end. So my asymptote is y equals -3. So then what I do with that, all right, sorry about that. Okay, so my asymptote is the y equals -3, and then I'll put that on my graph. So you do the horizontal line that passes through -3 on the y-axis. I already know this is going to be all real numbers, so now I just need to figure out some points. And again, you could type this into your y equals exactly as you see it, and then you can look at the table. If you hit graph and then you hit second graph, it'll give you the table. But let me plug in a couple things. So if I plug in a 1 here, that would make this a 0 exponent, so that's easy to do. And if I plug in a 2 here, that would give me 2 minus 1 is 1, so that's easy to do. So I'll use 2. So you can decide what you want to use. So then we're going to do 4 times 2 to the 1 minus 1 minus 3. So that's 2 to the 0 power, which is 1. 1 times 4 is 4, minus 3 is 1. Then I do 4 times 2 to the 2 minus 1 minus 3. So 2 minus 1 is 1. 2 to the first power is 2. Times 4 is 8. Minus 3 is 5. Okay. So 1, 1. And 2, 1, 2, 3, 4, 5. And then your shape is growth, so it's going to look like this, leveling off at -3. Okay. Okay, well, the range then is going to match y and -3, and we're using all the y's above, so it'll be greater than. The only other thing we need to do is to compare, because there will be some problems where I just give you the equation, I say compare it to its parent function like we did in the functions chapter. So the 4 is going to make it steeper, so it's increasing faster, or we also said narrower, but steeper makes more sense with this since it's a curve that's kind of increasing. The -1 means we shift to the right one, because remember it's opposite, and then down 3, because we keep the sign of the K, and that goes down. Okay? All right. So now, on example 3, so I want you to pause this, and you're going to describe the translation compared to its parent function, and then state the asymptote. So you don't have to graph these, so just say how it's moving around, and then what the asymptote is. Okay, so on part A, the comparison is shifts up to, all it does, and then the asymptote, which I'll just use capital A with the colon, is going to be y equals 2. Now you have to put y equals 2. If you just wrote 2, you would lose half a point because it's the equation of the line. So you need y equals with the number. Okay, then on part B, the 1/2 makes it increase slower, or it's wider. And this x minus 3 here, it's opposite of what it looks like, so it shifts right. No k value, which means that the asymptote has to be y equals 0. So again, you have to have the y equals or you'd lose half a point because it's the equation of the line. Okay? All right, so you try these. So go ahead and pause. This is just asking for the asymptote. So all you have to do for part A and part B, there'll be some problems where I just say, give me the asymptote. That's all you have to do. Go ahead and pause it and try it. Okay, so on A, your asymptote should be y equals -3 because it's the k value is -3. And for part B, it should be y equals 5. So hopefully you copied these down because they're not on your notes, and then you also did them over here. Now these don't count as questions, that study questions, because I gave them to you. So remember, you can go back and do some examples as part of your study questions, and then also write your summary. And that's the end of notes.